Okay, so now we're going to talk about fence posts. So I want to say, if this, instead of being a shape made out of the blocks like we had here, that it was just like a garden or something.
Yeah.
And I put a fence post
on every corner?
Well, not even necessarily at every corner, because I'm going to put one there, 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 and there.
Yeah.
So you see, so at the corner, on the outside corner, everywhere there's a cube.
So
okay?
Yeah. So what forms a right angle?
Well, but even here too, like where the original cubes that are kind of hidden here form right angles. So everyone. So we need to figure out how to count this, and it's not necessarily the easiest thing in the world to do. So let's before we jump into here, let's go to a simpler problem, which is usually a pretty good idea, right?
Yeah.
Yeah.
Well, let's just say we have a straight line, and let's say that line is, I don't know, 5 long, and I want to put a fence post every 1 unit. How many fence posts do you think I'm going to have?
Well, every 1 unit, 1, 2, 3, 4, 5, and then you got to put one at the end.
Ah, interesting. 1, 2, 3, 4, 5. There's 6, but you can see there's 5 units of 1. 1, 2, 3, 4, 5. So it's 5 long.
Yeah.
But it needs 6 fence posts. So you do have to be careful how you count this, and that shows why these fence post counting problems are a little tricky.
Yeah.
So let's go back and draw our shape, and before you count them, I just want you to guess how many you think there. Remember, the perimeter was 10, right? So we have a shape that sort of looks like this.
I think there's going to be 11 fence posts.
Okay, how come you think that?
Well, because with our line, it was 5 long, but you had 6 fence posts. It's 1 more.
Okay.
So this time the perimeter's 10.
Okay, so maybe that pattern continues. Maybe you get 1 more. What would you think?
Well, but it's not a line this time.
Okay, it's not a line. Maybe there's a difference because it's not a line.
But it's a bunch of lines. It's a bunch of lines put together.
Right, they connect up at the end. So do you have a guess for what you think the fence post is going to be?
I'm going to think 10.
You think 10. Okay. All right, so what can we do?
Just count them.
All right. 1. I'll mark there that we're starting, and then we'll just walk around, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
I wonder how many spaces there are between them.
Well, remember, we said the perimeter was 10, so we can count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Huh, so what's different about this? Why did a line of length 10 would have 11 fence posts, but when it's connected like this, it only has 10?
Well, because because if it's broken up here, there would be a fence post at the end here.
Ah.
Yeah, two fence posts have to join.
2 fence posts have to join, so when I have a line...
The fence posts don't have to.
Well, not only do they not have to, they just don't. But when I bend it together, magically, poof.
You have to snap those 2 fence posts together.
These 2 fence posts at the end, when I sort of bend this into a circle, these 2 fence posts come together to join there, so I only have 4. So you see I have 1, 2, 3, 4 sides.
Cool.
And 1, 2, 3, 4 fence posts.
Yeah, cool.
Yeah.
Here I have 1, 2, 3, 4 sides and 1, 2, 3, 4, 5 fence posts. Pretty interesting, right?
Yeah.
Okay, so you ready to do the same exercise with Penrose tiles?
All right.
Cool.
All right, here we go.